Welcome to Elementary Calculus, Chapter 2, Section 1, where we're going to talk about properties of functions. And it won't surprise you, probably, that one of the very important and maybe most important properties of a function is to make sure that we're aware of the domain and the range. The domain in particular. If you put the wrong value into a function, it might cause the thing to blow up, just like putting the wrong kind of fuel into your car might not get you out of the parking lot. So let's look at domain and range as pertains to functions. I'm not going to read every word on every page because you know how to read, presumably. But don't forget that domain is the list of x values or input values that we're allowed to put into a function, and the range is the list of values that come out of the function. Sometimes we think of those as y values. And in this first example, we're being asked for the domain of this function. And when you're working with a function that has the variable in the denominator, the thing that you really want to watch out for and try to avoid is accidentally or inadvertently putting in an x value that would cause division by 0. So let's maybe write down a little statement that says that the denominator of this function is not allowed to equal 0. Now, unfortunately, I'm recording from my office at work instead of my home office, and I have left my Apple Pencil, because I'm writing on an iPad to deliver these notes. I left my pencil at home. So I'm using this pencil, the end of my index finger today, which is not as sharp as my pencil. So unfortunately, in this relatively short video, I'm going to be writing with the end of my finger. So my handwriting is going to look even more like a kindergartner than it usually does. But I promise that in future videos, at least the vast majority of future videos, I will be using a proper writing utensil. Promises, promises, huh? Alright, let's get the domain of this thing. Our initial statement, our observation, is that x squared minus 3x minus 40. Look at that 4. Isn't that, oh, it's so embarrassing. I don't like it. Oh, that's better. Is not allowed to equal 0. We don't want our denominator to equal 0. And what x values are going to make this happen? You could solve this equation a few different ways. You could take it and plug it into the quadratic formula if you wanted to. Faster, though, would be to see if maybe we can factor it. And in order to factor this, our hope is that we can rewrite it as a couple of binomials being multiplied together and having it still not equal 0. So we need a number here and a number here that multiply to negative 40 and that add to negative 3. So I need those two numbers to be 3 units apart from each other. So 1 and 40 are not going to do it. 4 and 10 are closer together, but not quite close enough. But I think that 5 and 8 are the numbers that are going to put us 3 units apart from each other. But we need to add them together so that they equal negative 3. So that I'm going to make the larger of my two numbers negative. I'll make the smaller one, the 5, the positive value. And if you did multiply these two numbers together, you'll get negative 40, and they definitely add to negative 3. If this equation were to end up equaling 0, an x value of negative 5 would make that happen, or an x value of positive 8 would make this thing equal to 0, so those are the numbers that we're going to avoid. Let me see if I can move this other window down a little bit so that my email notifications stop popping up and joining us. There we go. Alright, so these are the numbers that we don't want x to equal. I'm putting a little slash through those equal signs. So this is a list of the x values that we're not allowed to use. It's more typical when you're answering a domain question to give a list of x values that you are allowed to use. So I'm going to say that we can use anything from negative infinity all the way up to negative 5. Or we can choose from x values between -5 and +8, or we can choose from x values that start at 8 and go all the way up to +infinity. So using interval notation, I'm taking this interval, and this interval, and I'm joining them together with the union symbol. That's what this U-like shape is here. It unites those three intervals into one answer, let's say. So that box around those three interval notations joined by the union symbol, I put a box around it because that's my final answer. Next, we want to give the domain of this function. So this one's different. It's not a fraction, obviously. It's a square root. And is there anything that we need to avoid when we're square rooting and that we need to look out for, especially because the variable is underneath the radical? And the answer is yes. We want to make sure that we don't take the square root of a negative number. We can take the square root of 0. That's okay. Square root of 0 is 0 because 0 times 0 is 0. However, we don't want to take the square root of a negative number, so let's write down a similar statement that says that 6 minus x needs to be greater than or equal to 0. In the previous problem, I sort of wrote down what I didn't want to happen, but in this case, and that's why I'm saying it out loud and making the point to really kind of highlight it, this is what I do want to happen. I want my x values to allow 6 minus x to be greater than or equal to 0. To solve this inequality, I'm going to add x to both sides, leaving the 6 on the left-hand side. X appears on the right-hand side. And this is a little atypical to have the variable on the right-hand side of the inequality. So I'm going to grab this entire thing and sort of mirror it or flip it over so that the x is on the left, but it's still on the sort of pointy side or the less than side of that inequality symbol, and the 6 moves over to the right. So we're looking at, or we want to only use, or the domain consists of x values that are less than or equal to 6. You could conceivably deliver this as your final answer, this format. It would maybe also appear more formally using set builder notation, which says that the set of x values such that x is less than or equal to 6. Every once in a while we run into that format, usually when there's more than one restriction on your x values. But here there's only the one restriction, and then of course interval notation is a very common way to deliver our final answer. X values have to be less than or equal to 6, so we're going all the way down to -infinity, coming all the way up to +6, and including the 6. The or equal to part of that inequality tells me that we're including the 6 as part of our domain, and in interval notation we include the 6 by using the square bracket or the closed bracket, some of us call it, but -infinity and +infinity always take the open bracket or the parenthesis. You're welcome to read that caution. There are other domain restrictions that you run into when working with functions, but at the moment we're just going to focus on those two, avoiding division by 0 and avoiding taking the square root of a negative number. And then inside this example is sort of a little switch of topic. It doesn't immediately relate to the little cautionary tale above this green box. What we're looking at here is called the difference quotient, f of x plus h minus f of x all divided by h. And we want to apply that or use it with this given function f of x equals 8x squared plus 6x minus 3. So how is it that I go about using the difference quotient, which is this thing, in conjunction with a given function? I see a lot of students take these two ingredients and mix them together in the wrong order. So pay close attention to the way these two things are going to interact. Don't write this down, But remember that if I asked you for f of 2, then you would take the number 2 and you would plug it in here in place of anywhere that you see an x. So you'd have 8 times 2 squared plus 6 times 2 minus 3. In this case, however, we're not plugging in a value of 2. We're plugging in a value of x plus h, which means that since this x got replaced by an x plus h, we're also going to replace this x and this x with an x plus h. So let's do that and just write down what f of x plus h equals. We'll sort of amass all of our ingredients. Even though I said there's only 2, when I look at this thing I see 3. Sort of different tasks that we have to perform. So f of x plus h equals, we're taking the x plus h and plugging it into our function, so we have 8 times x plus h, quantity, squared, plus 6 times the quantity x plus h. Maybe if I use my pinky finger, does it get any more accurate? No, it's just weirder feeling. I don't like writing with my finger on my iPad. And now we've got some arithmetic to do. I've got to take the x plus h and square it. I have to take x plus h and multiply it by itself, like x plus h times x plus h. FOIL, combine like terms. I'm not going to write out all of that because you're already in, my students who are watching this video are already in elementary calculus. You've been through enough algebra, so let me not pummel you with algebra. I'm going to FOIL this and combine like terms. I'm going to do that in my head, and I get x squared plus 2xh plus h squared. And then the next term becomes plus 6x and plus 6h. And then finally, the minus 3 comes down. All right, I wrote those in different colors to illustrate that they are the result of those 3 terms above. Now we'll distribute multiplication by 8. 8x squared plus 16xh plus 8h squared, and then all these remaining terms, nothing to do with those, so I'm just copying them down. And can I combine like terms? I'm looking. I can't even combine any like terms. Amazing. All right, so that's f of x plus h. Now, notice that up here in the difference quotient, the other thing that we see is a minus f of x. I don't have any work to do in order to figure out what f of x is. It's right here. It was given to us. And to figure out, still in the difference quotient, I don't have any work to do to figure out what h is. That's the denominator. It's just an h. So let's build this thing by replacing f of x plus h with this mess, and we'll replace the f of x with what f of x is, and then we'll divide the whole thing by h. You're doing this with pencil or pen, so you could probably rewrite the difference quotient down here and then set it equal to, and then it's going to be a ginormous fraction. The numerator of the fraction is going to be 8x squared plus 16xh plus 8h squared plus 6x plus 6h minus 3, and then we have to subtract, so I'm going to switch pen colors here. Give me something dramatic. Let's move over to blue. There we go. We have to subtract f of x. That's 8h squared plus 6x minus 3. And then that whole thing gets divided by h. All right, there we go. There's all of it. The thing we have to be careful of at this stage in the process is this. Here's where I'm subtracting f of x. and you'll notice that the minus sign is there outside the parentheses, but that I took my function f of x and I put it in parentheses. That's necessary so that the next thing I'm compelled to do is to distribute this minus sign. And that's going to change the sign on all three of those terms. So that's what we're going to do next. This is a little tedious to write out. Just be glad that you're not writing it with your index finger and that you're actually using a proper writing utensil. Alright, so we're writing out the whole thing again. That was not even an 8. Here we go. 8x squared. Alright, now I'm going to distribute that minus sign, which gives me a minus 8h squared minus 6x plus 3. Still all divided by h. Boy, we're really making a whole big deal out of this, aren't we? Why? Distributing that minus sign was really important because now we're going to combine like terms. And normally I would write, can I fit this on the screen? I'd put a little note over here, CLT for combined like terms. And actually up here I would put DIST for distribute, because that's what I did in order to get down to this line. And before that, we were really just doing a substitution up here, trying to get a better feel for what f of x plus h was. Alright, so now that it's time to combine like terms, I'm noticing that this positive 8h squared and this negative 8h squared are going to cancel out. And this positive 6x is going to cancel out with this negative 6x. And lastly, where'd my positive 6x go? I thought I had circled that. Oh, I did. There it is. Okay. I saw the 6h and got confused. And lastly, this minus 3 is going to cancel out with this plus 3. So those 6 terms disappear, and that's only going to happen if you make sure to distribute that minus sign in the previous step. That's going to get all of those signs opposite from one another, which allows us to rewrite our fraction again, but there's going to be considerably less stuff in it this time. 6 fewer terms, in fact. Wow, there's only 3 terms. That was nice. Still all divided by h. It would be nice if we could do some reducing here. And unfortunately, something's the matter. I've made a mistake. Easily fixed, though. Sort of easily. The part that's not easily fixed is the circling would be difficult for me to erase. The mistake that I made is if you look in the top left corner, right under where you see me in the top left corner of your screen, the thing that I circled there is called the difference quotient, and in the numerator it says minus f of x. And we talked about the fact that this is f of x. And then when we plugged this into the difference quotient, I wrote it down here, except I wrote minus 8h squared. That was supposed to say minus parentheses 8x squared. So that's the fix that we have to do. So I'm going to just kind of go, well, let's see, I can sneak my eraser in here and get rid of that h, or most of it anyway, and make it an x squared. And then I'll come down to the next line and make this one. That should now say minus 8x squared. And then what impact does that have? The impact of changing this into a minus 8x squared is that when we were canceling out or combining like terms, I should say, it's not going to cancel out this minus 8h squared term. So I'm going to erase at least some of the circling that I did around that. It's going to cancel out, however, this 8x squared. So the 8x squared and the minus 8x squared, those two terms are going to cancel each other out. This positive 8h squared term is still going to be there, which means that this, on our last line, now needs to say 8h squared instead of 8x squared. So let's go in here and change this x to an h. 8h squared. Perfect. Alright, sorry about that. I'll tell you how I caught that problem, though, is because when I got down to this step right here, I know, because I've done a lot of these problems, I know that the h from my denominator was actually supposed to cancel out with, or reduce with, all three terms in the numerator. And when this first term didn't have an h in it, you might have seen the look on my face. I was like, something's not right. At least I was right about something not being right. Okay, so what's the very last step of this process is to reduce or simplify. And when you have a fraction like this, you have to distribute your division the same way you would distribute multiplication. So I'm going to be reducing here, and here, and here, in order to write a final answer of 8h plus 16x plus 6. And when we get a little bit further along in this semester, we're going to apply a thing called a limit, LIM, and we're going to take our h value and send it off to 0, which is going to get rid of that first term, and then we'll only have two terms left. But not yet. Let's put a box around that as our final answer and move on down to the next page. This is a topic that you're undoubtedly familiar with. It's called the vertical line test. The vertical line test helps us determine if a graph is the graph of a function. And if we can pass, well, let's read this definition. If a vertical line intersects a graph in more than one point, the graph is not the graph of a function. I can draw vertical lines through this curve all day long, and each one of those vertical lines is only going to hit my curve at one point. So that is the graph of a function. However, looking at this circle, all I have to do is take this one vertical line, and you'll notice that it's crossing my circle at 2 points, here and here. Well, that second one was a little off. Here and here, one vertical line is crossing through my graph at 2 points, or more than 1 point. Therefore, this is not the graph of a function. This point right here has an x-coordinate. This point right here also has an x-coordinate. The x-coordinates of those points are the same. They look like they're both at about negative 2.8. Repetition of an x-coordinate is another way that you can notice or prove that you're not working with a function. We're not allowed to repeat the use of x-coordinates if we're working with a function. No repeated x values, and no vertical lines crossing our graph more than once. And lastly, I believe, we want to look at this topic, even and odd functions. It seems maybe even arbitrary to call a function even versus odd, but just realize that those are the vocabulary terms that we're working with here. And something that should be written into your notes is this definition of an even function. A function's even if it's even if I can plug in a negative value or plug in the positive version of that same value, like plugging in a -3 and then plugging in a +3, and if the output value from my function is the same, whether I plug in a -3 or a +3, then the function is called even. And we're going to see an example of it. Just below that is the definition of an odd function. It's not just the definition of an odd function, we're also going to use this little equation that's inside of here, f of -x equals -f of x. That's also a test that we can do to see if a function is even versus odd. So this one, if our function passes that test, then it's an odd function. Certainly if our function fails both of those tests, then it would be categorized as neither even nor odd. Alright, so let's try this one. I always do these in this order as far as doing my testing, so let's see if this function is even. Oh, I should note, your function is not going to be even and odd. Could a function be even and odd? Maybe a function, maybe the equation, oh no, it can't be. I was thinking maybe a circle, except the circle is not a function. Alright, so let's try f of -x. Or you could even do f of -a if you wanted to, but let's use f of -x, and what that looks like is I'm replacing this x that was previously being squared, I'm replacing it with a -x, and we're going to square that, and we'll still subtract 3. What is -x squared? Well, that means -x times -x, and you know that a negative times a negative makes a positive, and the x times the x makes an x squared. And we still have the -3. So the only thing that changed from here to here was squaring a -x. The result was positive x squared, and wouldn't you know it, f of -x is equal to f of positive x. Therefore, our function f is even. That wasn't so bad. It's a little strange to plug in -x as your input value. I just did this recently. You might want to consider, instead of making this the test that you do, maybe it might make more sense to you to see if f of -a is equal to f of positive a. Instead of using x's in place of x's, that can get confusing. Try doing it with f of -a and see if it equals f of positive a. We'll do it with a's instead of x's in the next problem, and we'll see if you like the way that looks. We could go through the process of testing it to see if this is an even function. I happen to know that it's not, so I'm going to skip it and test this to see if it's an odd function. To see if it's an odd function, remember that we're still going to need to determine f of -x, and then we'll need to negate the entire function, negative f of x. So first, let's calculate f of, and let's do f of -a. That'll be equal to 8 times -a to the third power plus 6. A negative being raised to an odd power, in this case the third power, is still going to be negative. And the a times a makes a to the third. So this is going to be 8 times -a to the third. And the plus 6 is still there. And then ultimately this gets written as -8 times a to the third plus 6. I was able to take these items and move them around and write it like this because they're all really connected by multiplication. Really, this says 8 times -1 times a times a times a. It's all times. It's all multiplication. so we can move it around, change the order. Great, so that's f of negative a. And then let's also look at, just switching colors here. Let's use green. We also need to, we're going to compare this to negative f of a. So we're going to negate our entire original function. So that's negative 8a to the third plus 6. And if we distribute the minus sign there, we get negative 8a to the third. Oh, it's looking like maybe they're going to be equal to each other. Oh, we have to distribute this minus sign to the positive 6, though. So that's going to make it into a negative 6. Therefore, we can see that f of negative a is not equal to negative f of positive a. Therefore, not odd. You're not going to put a box around this because saying what it's not is not an answer. If you do the test to see if f of x is an even function, you'll find that that also fails. In fact, that's a pretty quick one. We can do that one. Let me grab another color. See if this sort of fuchsia color works. All we have to do now is, as a matter of fact, we have everything that we need. We're going to compare f of negative a to f of a. And I can see that f of a does not equal f of negative a. Therefore, this is not an even function either. F of a does not equal f of negative a. Therefore, not even. So it's not even, and it's not odd. The correct answer would be neither. And that, ladies and gentlemen, is Chapter 2, Section 1. Thanks so much for joining me, and I will see you again, or you'll see me again, in 2.2. Thanks.